Now in this lecture we are going to implement circular queue using array. So we are going to implement the methods that we have explained in the previous lecture. So in this lecture we are going to implement 4 methods. So the first one will be creation of the circular queue, then the second one will be isEmpty method, and the third one is isFull method, and the fourth one is going to be Enqueue method. Then after implementing these methods in this lecture, the other methods will be implemented in the next lecture. So let's get started. So here the first thing that I'm going to do, I'm going to create a new file which will be the circular queue. So inside this file I'm going to create our circular queue class. So I'm going to declare our class like this: public class circular queue. Now inside this class, the first thing that we are going to do, we are going to declare our array, and we are going to declare the top of the queue, beginning of the queue, and size of the queue. Now here we are going to create the type of the integer queue, so that's why the type of array will be integer. So I'm going to declare array as ARR. Then the top of queue will be the integer, because here we are going to save the index of the queue. Then the next variable will be beginning of queue, and then we are going to declare size of queue over here. Now the reason that we are declaring size over here is, in case of circular queue, we are going to use this one while we are using enqueue and dequeuing method. So here, then inside constructor, I'm going to initialize this array in the memory, and we are going to set the top of queue and the beginning of queue to -1. Now here it's going to be like this: public circular queue. So here we know that it's going to take as a parameter size, because here when we are declaring a circular queue, we have to create an array with fixed size. Then I'm going to instantiate the array with this size over here. So this array will be new int with the size that we are receiving from parameter. Then we are going to set the size that we declared over here to this size that we are receiving from parameter. So size will be equal to size. Then this top of queue will equal to -1, and this and beginning of queue will set to -1. So when we have set these variables to -1, it means that we don't have any element in our circular queue, so our circular queue is empty. Now after doing so, I'm going to print out to the console that the queue successfully created with the size of this size that we received from the parameter. So I'm going to print out to the console system out print. So let's put it like this: the circular queue is successfully created with size of. So I'm going to concatenate this size over here, then finish. Now with this we have completed creation of queue by using this constructor over here. Now let's see how this is working in practice. So as we said in our previous lecture, that when we are creating a circular queue, we are just creating an instance of this circular queue class over here. So here I'm going to create the circular queue like this. So it's going to be like this: new circular queue is equal to new circular queue like this. For example, let's say we are creating with the size of 3 over here. Now if I do so, our circular queue is created in the memory. Now let's run our code. You will see that the message is printing out to the console saying that the circular queue is created. Now here you see that the circular queue successfully created with the size of 3 over here, because we have set the size 3. So with this we have successfully implemented creation of circular queue using array over here. Now let's see what's the time and space complexity for this method over here. Now as always, we are going to start from the first line of the method over here. So in the first line we are just instantiating the array with this fixed size. So this instantiation will take a one-time complexity. Then we are updating the size with the size that we are receiving parameter. So this one also will take a one-time complexity. Then we are updating the top of queue to -1. So this is just simple assignment statement, so this will also take a one-time complexity. So then we are setting beginning of queue to -1, so this one also will take a one-time complexity. Then we are printing out to the console the message which says that the circular queue is successfully created. So this means that this one also will take a one-time complexity. Now if we combine all these complexities over here, we will get a one-time complexity. Now the space complexity in this case is on, because here when we are setting the fixed size of array over here, it's allocating a number of cells contiguously in the memory. So it's taking space in the memory. So that's why, based on this size parameter, the space complexity is on. even though we are using these cells or not. So the cells will be allocated in the memory contiguously, so that's why it will take size in the memory. So that's why the space complexity is ON. Now let's continue to the next method. The next method that we are going to implement is empty method. So I'm implementing isEmpty and isFull method in the beginning because we are going to use them in our Enqueue and dequeue methods. So here I'm just going to comment out isEmpty. Then I'm going to declare our method over here. Now we know that isEmpty method will return true or false. So while we are declaring it, I'm going to put boolean as a return type. Then it's going to be isEmpty. So as we mentioned before, we can identify the queue based on the top of queue or beginning of queue. So if the top of queue and beginning of queue points to the -1, it means that we don't have any element in our circular queue over here. So we can use any of these variables over here. So in this case, I'm going to use the top of queue. So this means that if top of queue is equal to -1, in this case, we can return true because our queue is empty. Otherwise, we are going to return false because otherwise it's going to be some elements in our queue. So this means that it's not empty. So with this, we have successfully implemented isEmpty method. Now let's see how this is working in practice. Now when we are creating a circular queue, we know that we don't have any element in this circular queue over here. So this means that if I run isEmpty method now, it should return true that this is empty. So if I call isEmpty method like this, I'm going to create a boolean variable over here, result, and set the return that we are getting from isEmpty method to this result over here. Then I'm going to print out this result to the console to see that what is it's printing out. So here I'm going to put result. Now if I run our code, first you will see that it says that the circular queue is successfully created, then it's returning true. So this means that in this case our circular queue is empty. Now our method works very well. Now here we have implemented the method successfully. Now let's see what's the time and space complexity for this method. Now the time complexity will be O1 because here we are just taking the top of queue and based on that we are returning true or false. Now these 3 lines of code over here will take O1 time complexity. So the time complexity for isEmpty method in case of circular queue using array is O1. Now the space complexity is also O1 because here an extra space is not required to perform this operation over here. We are just checking the top of queue and based on that we are returning true or false. So this is not space consuming operation, so that's why it will take O1. Now with this, we have successfully implemented isEmpty method. Now the next method that we are going to implement is isFull method. Now in case of isFull method, the logic is different from the linear queue. So here we have 2 conditions. So first we need to identify if we add 1 to the top of queue and we are receiving the beginning of queue, then in this case our queue is full. So if we have completed a circle, then we can say that the queue is full. So that's why I'm going to declare our method like this. Public boolean, so I'm going to put the return type as boolean because it's going to return true or false. So here the first condition is going to be like this. If top of queue plus 1 is equal to beginning of queue, in this case our array is full because here we have completed a circle, then we can say that the queue is full. So I have explained this part in the previous lecture with the animation. So if you don't understand how this is working, you can go back to the previous lecture and look at the logic there and you will understand how this is working. Now in this case we are returning true. Otherwise our second condition will be like this. So if beginning of queue points to the 0th index and top of queue points to the last element in the array, it means that this queue is full. So here I'm going to put like this. If beginning of queue is equal to 0 and top of queue plus 1 is equal to the size, then in this case it means that top of queue is located at the last cell in the queue. Then in this case we are going to return true because our queue is full. Now otherwise, in the else condition, in all other cases we are going to return false because our queue is not full. Now let's see how this is working in practice. So here, if we call this isFull method for this circular queue that we create over here, it's obvious that it's going to return false because in this case it is not full. So instead of isEmpty method, I'm going to call isFull method and run our code. You'll see that in this case it returns false because here our array is empty, so it's not full. So in this case it has to return false over here. Now let's see what's the time and space complexity for this method over here. So here in the first line of method we are checking top of queue plus 1 with the beginning of queue. So this part will take O1 time complexity. Then we are continuing returning true over here. So this one also will take O1 time complexity. Then in the else if condition, we are checking that if beginning of Q is equal to 0 and if top of the Q plus 1 equals to size. So these are just simple if condition over here. So this means that it will take O1 time complexity. Now we know that returning true or false also takes O1 time complexity. So if we combine these complexities over here, we get O1 time complexity. Now the space complexity is also O1 because here an additional memory is not required to perform this operation. Here just we have if conditions and returning true or false. So extra memory is not required over here. That's why the space complexity is O1. Now with this we have successfully implemented isFull in case of circular queue using array. Now the last method for this lecture that we are going to implement is Enqueue method. So Enqueue method is one of the important methods in the queue. So basically isFull and isEmpty methods are helper methods for using inside Enqueue or the queue method. So here I'm going to declare our Enqueue method like this. Now we know that when we want to insert an element to the queue, in this case we are using Enqueue method. So it's going to be like this, Enqueue. So I'm going to declare our method like this, public void. So our method is not returning anything. So that's why I put void. So the parameter that's going to take is value, which will be the type of integer because our queue is the type of integer. Now the first thing that we are going to check over here, that we are going to check that if our queue is full, in this case we cannot insert any element to our queue. So in this case I'm going to return to the console saying that the queue is full. So first if condition will be like this, is full, then we are printing out to the console saying that the queue is full. Now here in the else condition, we are going to check that if the queue is empty, so here we have to update the beginning of queue as well. But if it is not empty, we are not touching the beginning of queue. So that's why we will have two conditions over here. So in the else if condition, we are checking that if the queue is empty, this means that this is the first element that we are inserting to the queue. So as you know, when we are declaring a queue, we have set the beginning of queue to -1. So in this case, we have to change the beginning of queue to point to first cell, which is located at the index of 0. So here, the first thing that I'm going to do, I'm going to set the beginning of queue to 0. Then we are going to increase the top of queue by 1. So because here top of queue points to -1, so you need to increase it by 1 to point to the 0 over here. So then we are going to update the first cell's value to this value that we are receiving over here. Now top of queue points to the first cell, so if I put something like this, ARR with the top of queue index to value, we are updating the first cell's value in this case. Then after doing so, we can successfully print out message to the console saying that the value successfully inserted in the queue. So the message will be like this, system out print successfully inserted, this is the value that comes from the parameter, in the queue. Now with this, we have successfully inserted first element in the queue. Now we have another case in which, for example, we have elements in our queue, so we want to insert an element at the end of queue over here. So this means that we are going to write this condition in the else part of this if condition. Now here, as we said before, in case of circular queue, we have to use unused cell in this case. So to do so, we have to write some conditions over here. So if the top of queue points to the last cell and we have empty cell in the beginning of the array that we have created over here, so this means that we have to insert element at the beginning of queue. So this means that the top of queue has to point to the first cell in the array over here. So for this, I'm going to write if condition like this. If top of queue plus 1 is equal to size, it means that top of queue is located at the last cell, but we have empty cell at the beginning of array over here. So in this case, we are going to set the top of queue to 0 because it has to point to the first cell in this case. Otherwise, we are going to increase the top of queue as we did before by 1. Now with this, we have identified the top of queue in the array. So then after identifying this, we are going to update that value in the array over here. So top of queue has to point to the value over here, to this value that we are receiving from parameter. So in this case, I'm going to update top of queue cell to this value over here. Now after doing so, we have successfully inserted an element at the empty cell that we have in our array over here. Now after implementation, we are going to print out this message to the console again over here. Now with this, we have successfully implemented our Enqueue method in case of circular queue. Now here, basically what we are doing is, first we are checking that if the queue is full, so in this case we are returning circular queue is full. Otherwise we are checking that if our array is empty, it means that we have to insert first element to the queue. So this means that we are going to we need to update the beginning of queue in this case also. Now then the else part of this code over here is implemented for circular queue. So here, first we need to identify the top of queue, then we need to update the top of queue to this value over here. So with these conditions over here, we are identifying the top of queue and updating the value of cell which is located at the top of queue. Now with this, we have successfully implemented this method. Now let's see how this is working in practice. So here we have created new circular queue. So I'm going to call Enqueue method for this new circular queue over here. So I'm going to insert 4 element, even though our circular queue's capacity is 3. So in this case, to check that if this is working correct or not, I'm going to insert 4 elements. So at the end, it should say that the queue is full. So if I run our code, you see that the queue is successfully created with the size of 3, then successfully inserted 10 in the queue, then successfully inserted 20 in the queue, and then successfully inserted 30 in the queue. But at the end, when we are enqueuing the 40 to our queue, it says that the circular queue is full because the capacity of circular queue in this case is 3. So our method works successfully. Now let's see what's the time and space complexity for this method over here. Now as always, we are going to start from the first line of this method over here. Now in the first line, we are checking that if this queue is full or not. So isFull method takes O1 time complexity. Then we are printing out message to the console. So printing out message to the console takes also O1 time complexity. Then we are checking that if this queue is empty or not. So isEmpty method also takes O1 time complexity. Then inside this else if condition, we are updating the beginning of queue and the top of queue increased by 1. Then we are updating the cell of the array to the value and printing out message to the console. So all these 4 lines of code will take O1 time complexity. So this means that this part of code will take O1 time complexity. Then in the else condition, we are checking that if the top of queue plus 1 is equal to size, we are updating the top of queue to 0, and then we are increasing the top of queue by 1 in the else condition. So this if condition over here also will take O1 time complexity because each line over here takes O1 time complexity. Then at the end, we are updating the value of cell in the array, so this will take O1 time complexity. Then we are printing out to the console this message, so this will also take O1 time complexity. Now if you combine all these complexities over here, it takes O1 time complexity because here time consuming operation is not performed. Now the space complexity is obvious that O1 because here we are just updating the variables and the value of cell in the memory. So this means that it will take O1 time complexity. So an extra memory is not required to perform these operations over here. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented creation of circular queue, isFull method, isEmpty method, and Enqueue method in case of circular queue. So hopefully everything is clear about these methods. Now in the next lecture, we are going to implement the queue method, pick method, and delete method in case of circular queue using array. So see you in the next lecture.